Hi. Today we're going to talk about measurements. You'll find today's stuff no problem at all. So relax. We have to get some vocabulary down. In fact, most of the problem you have in statistics will be vocabulary. The word that you think means this means to statisticians something else. There are some vocabulary words which you have vaguenesses about, and if I make them a little more precise, you will be happy because you'll know what they mean. But there are some which you already know the meaning of, which I'm going to change. That will come later on. Today won't be that bad. We'll start off with some things which are pretty straightforward. Let's get started. Precision. Precision, well, I'm not going to define it as Webster would. I'm just going to say precision refers to the number of decimal places that something can be measured. It pertains to the number of decimal places. It pertains to it. What do you mean by that? Well, an example is worth 1,000 words. Here is a couple of rulers. If I put this against something and measure it and it comes out over here, I would say, oh, the length of the thing that I'm measuring goes from here to here is 1.6. Is that? I really can't say more. 1.5, 1.6, it's about 1.6. If, on the other hand, it came 1, 2, 3, 4, 5. If it came over here, my measurement, it fit over here. If I use this kind of ruler, what I could say is, oh, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and I could, no, it's not 1.6. It's really 1.55. I can read this ruler to one more decimal place than I can read this ruler. This I said 1.6. Here I'm saying 1.55. I could read this one more decimal place than I can read this because this ruler is more precise than this ruler is. This is a more precise ruler. This has markings which allows it to be more precise than that one. Okay? No problem. We all follow that. The next word that people often confuse with precision is accuracy. Accuracy is not the same as precision. Accuracy refers to the correctness of what is being measured. Now, this concept, I have to give an example to make sure we understand this concept. It's not absolutely trivial. Let's try an example. Okay, I have a couple of rulers, and I put this ruler down, I measure something, and it's that long. And I say, oh, 1.5. Okay, 1.5. That's what I say it is. That's how long it is on this ruler. On this ruler, I measure the same thing, and it's comes out over here. Okay. I say, oh, it's really 1.82. This is 1.82. I can read this ruler more precisely than I can this one. And I can read it to another decimal place, so I say 1.82. That's how big it is. And then there's one little problem, one little bitty problem. This ruler is broken. Notice, they're at 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 units between 1 and 2, but between the edge of the ruler and 1, there's only 1, 2, 3, 4, 5, 6. There's only 7 units. There's 1 unit, 2 units, and 3 units missing. So if I were to move what I was measuring down to the end of the ruler, it would only come up to here, to about 1.52, not 1.82. This ruler is very precise. However, it's inaccurate. Accuracy is what you're measuring, is the correctness of what you're measuring. This is measuring correctly. It's measuring the right thing 1.5 is as close as it can measure it, but that's what it's measuring, something that's about 1.5 units long. This thing measured 1.82 very precisely, but it was measuring something that was only 1.52 units long, or approximately that long. So it was imprecisely. It was precisely measuring something inaccurately. Funny looking words. It's precisely measuring inaccurately. Now, we do not want to measure something inaccurately. It is extremely important that we are accurate, that we're measuring the right thing. If someone says, how many days in the year are there, and you say 30, you're answering how many days in a month there are, not how many days in a year. You're not answering the right thing. It's not a question of precision. Oh, I forgot leap year. It's totally wrong. You're answering the wrong question. Well, if you're measuring something with an inaccurate instrument, you're measuring the wrong thing. It's not what you want to be measuring. And that's unacceptable. Two instruments, one more precise than the other. I like the precise one if it is accurate. First comes accuracy. Two instruments, they must both be accurate before I would even consider comparing them. If one is accurate, the other isn't, throw away the inaccurate one. You always want accuracy. Then, after accuracy, comes precision. But they're not the same concept. And many people use the word, oh, this is an accurate measurement, meaning this is a precise measurement. Okay? Accuracy is how correct it is. Precise is once I got the correctness, now how close can I get to it? How close in there can I get? Okay, next word, a parameter. Now, you got to be careful with that word parameter because different scientific disciplines use different words, different meanings to the word parameter, and different words for what a parameter is. A parameter, easiest way I can do it as a concept rather than a Webster dictionary type thing, is to say a parameter is that which we're trying to measure. We're trying to measure something, and that which we're trying to measure is the parameter. Okay, I have here a book. Okay, I happen to have written a book, but that's immaterial. What I want to do is talk about how long the book is from here to here. What's the length of the book up and down, or now sideways? That length is what I'm trying to measure. That length is a parameter. There's a true value to that parameter, a true value. But I don't know what that value is. Now, if I'm allowed to say this on TV, God knows what the value is. He looks down and he knows. To him there is a value to this length. Okay? There is a value there, but it's unknown. I don't know what it is, and so I'm going to measure it. I'm going to measure it. Well, most of us think if we measure it, we know what it is. That's not true. A measurement is the value we obtain when we measure. This doesn't say anywhere a measurement is a parameter. Nothing. It just says a measurement is the value we obtain when we measure. And what that means is God saying to us, hey, I know you're not perfect. I know you can't just look at the book and say how long it is. So I'm gonna let you do something. I'm gonna let you take a ruler, and I'm gonna let you do the best you can. And I put the ruler next to it, and I say 9 inches. It looks like it's 9 inches right on the money to me. So I say, and if I'm talking to God, I don't say it's 9 inches. I say 9 inches. You know, is that right? And now God chuckles, says, well, it's close. Because the true length has probably got an infinite number of decimal places, 9.01432, and so on and so forth. But I couldn't possibly measure it that precisely. So my 9 inches is close. Someone else might come and say, oh, no, it's 9.05. Someone, oh, no, it's 9.1. What's the matter with you? Oh, no, it's 8.9. Different people looking different ways at the ruler, or just moving the ruler or tilting it slightly, will get a different measurement than I get. And we're all doing the same thing. We're all taking a measurement. we're trying to measure the true length of the book. The true length of the book is an unknown, and we're making measurements of it. And we're trying to be accurate, we're trying to be precise, but our instruments are limitations on how well we can do. As a matter of fact, if lots of people were to try and measure that book, lots and lots of people, what would happen probably is their data would look something like this. That is, the true width of the book might be right here. And some people are going to get pretty close. Not exactly right, but they'll get pretty close to it. Others will be missing by a little bit. Others will be missing by more. And when two people give the same number, I put them one on top of the other. So I get what I call a distribution of data. A distribution of data. And most of the data is pretty dark. This might be 9. This might be 8.9 here. This might be 9.1 there. So most of the data is pretty close to 9. Most people who try and read it as precise as they can will give numbers pretty close to 9, which is going to be pretty close to the true width of the book. But there are lots and lots and lots and lots of different possible values that could come up. Nobody is right and nobody is wrong because it's not a parameter that they're doing. It's a measurement. And their measurement is the best they can do. It is a guess at the parameter, but it's not the parameter itself. And that is an important concept. That is an important concept that's going to take us most of the semester to get across. And that is, the parameter is something we can never really know. And a measurement is our attempt to get at what this parameter is. We must realize that we're not right. We must be humble and realize we're not exactly right, but we want to be close. We want to be close. And if someone else has a slightly different answer, we don't jump all over them. We talk to them and say, well, no, it looks more, don't you think that's a little high? I think mine's a little clear. Because who's to say you're right and they're wrong? You feel you're right, they feel they're right. There's going to be differences because we're not dealing with the parameter, the true value. Neither of us know the true value. We just are doing our best to get at it. Okay? So, data. Data. Statistics is all about data. Data. The data are the measurements themselves. Take a bunch of data, take measurements. Measurements are the data. We have data. Measurements. Now, the next and important thing that I want to talk about is a statistic. Finally, our namesake. Statistics has to do with statistics. And a statistic is just a summary of the data. That's all it is. A statistic is a summary of the data. Remember that. A statistic is a summary of the data. There are all kinds of summaries of the data. We'll be spending a lot of time this semester talking about different kinds of summaries of the data. And their function, they're for different purposes. Some statistics are used to describe the data. Some statistics are used to use the data to guess at a parameter. And if I had one measurement on the length of this book, and it said 9, someone said, well, how big do you think the book is? I'd say, oh, I think it's 9 inches wide. Yeah, 9 inches tall. That's what I think it is, 9 inches. That would be using the data, statistic, function of the data. My guess is a statistic. It's also my guess at a parameter. So I might be using a statistic to tell me what I think the parameter is. Now, I know it's not right, but it's what I think it is. Okay? So statistics can be used for various reasons. It can be used to help you make decisions. Should I take an umbrella to work today or not? I look at the information I get from the television, from the weather forecast, from the weatherman, his predictions, and I say, now I have to make a decision. I use this data, and I'm combine them in such a way that the answer is either take an umbrella or don't take an umbrella. My statistic is the summary of the data, which helps me decide to take the umbrella or not. This is, I know, at this point confusing. We will have lots of time to straighten it out during the semester. That's what we're here for, to learn about statistics. Okay? Have a good one.